This experiment introduces the theory, generation, and properties of laser radiation and uses it to observe diffraction and interference effects on a slit, single and double pinhole diaphragms, a grating, and a bar. The setup consists of an optical bench with helium neon laser, a diverging lens, a converging lens, objects where there is the slit, a bar, a pinhole diaphragm, a double pinhole diaphragm with 3 different hole distances and a grating, and of a stepping motor, a ground glass with photodiode, a DC voltage amplifier from 0.5 mV to 10 volts, an analog digital converter ADC, and a computer. Start the computer and log on. Start the laser control application on the desktop. This automatically performs a reference run of the motor and sets its position to 0. Switch on the laser. Use the diverging lens and the converging lens to widen the light beam. Before starting the experiment, think about how to position the lenses using the beam path. Remove the object from the beam path and check that the beam is parallel and that the entire beam is sufficiently wide and homogeneous and symmetrically illuminates all objects. Place the objects in the beam path and observe the patterns projected on the screen. Also compare them with the expectation. Look at the slit, the bar, the pinhole diaphragm, the double pinhole diaphragm with small hole spacing, the double pinhole diaphragm with medium hole spacing, and the double pinhole diaphragm with large hole spacing, as well as the grid. Now start measuring the intensity curve with the different objects. The distance between object and diode must be as large as possible and must be measured. The images themselves are computer controlled and are shown here as an example of the slit. In the measuring program, specify the measuring range for the diffraction pattern that the diode is to scan and the voltage range that is to be digitized by the ADC, 0 to 1 volts and 0 to 10 volts, depending on the intensity of the light. Make sure that you record symmetrical spectra up to the 4th secondary minimum left and right of the main maximum, and that the positions of the extremes can be clearly determined. You start the measurement in the application on the bottom left. Enter a step size that allows the highest possible resolution of the spectrum, ideally 50 steps. The measurement is completely computer controlled. The recorded spectrum is saved in a file and displayed during the measurement. The aim of the evaluation is to calculate the characteristic sizes of the objects, or in turn, also the wavelength of the laser light.